New Jersey, a state of innovation. What does that mean? So I'm going to focus on one sliver of a very rich history of New Jersey invention and innovation. As you can tell from this, there are a wide variety of aspects of invention and innovation in New Jersey. There are lots of places and people that have been involved in various kinds of inventive and innovative activity. But what I want to focus on today is understanding why New Jersey is not considered the center of R&D, right? Because at one time, it was. Right? So in the 1940s, 50s, and 60s, this is what the map of innovation in the U.S. looked like. And you can see that big blotch right there? That's New Jersey. Right? In fact, in 1960, New Jersey was known as the research state. As many of you know, New Jersey was a center of American industrialization. And there were several industries that were born here, that grew here, others that made New Jersey its home. Three industries in particular were centered in New Jersey for much of their history in the 20th century. The electrical electronics industry, telecommunications, the chemical industry, and the pharmaceutical industry. I'm going to focus mostly on the first of those and a little bit on the last, not so much the chemical industry, which has its own complex history that becomes a little bit more difficult to fit into the time that I have to talk to you today. So what I'm going to do is I'm going to use a few key individuals and places to talk about this broad sweep of R&D and innovation in New Jersey. And I'm going to start in the middle of the 19th century, in the 1830s. Anybody ever hear of Speedwell Village in Morristown? A few of you. So that was a very important center for iron innovations in iron products of various kinds, especially in transportation. Right? So Morristown is at the base of an area where there are rich iron mines, or at least there were in the 19th century, very rich iron mines. And the product of those mines were made into a variety of things. The Speedwell Iron Works actually began as a nail factory, but became a very innovative site for innovation, using a few key technologies of the 19th century. So the machine shop, where you had lathes and planers and drills and saws, and the skilled machinists that used those, literally built everything else. And we can see that at Speedwell. Right? So at the top there is the first transatlantic steamship. It was actually a hybrid, sail and steam. The engine was made in Speedwell. Railroad technology introduced in the 1830s in the U.S., and a lot of the early railroad technology was being manufactured and improved at Speedwell and other places like it. Speedwell is best known, however, for an entirely different technology. And this is going to be kind of the focus of my talk, what we call the second industrial revolution, right? The steam technology, the railroad, those are sort of the products of the first industrial revolution. The second industrial revolution is electrical and chemical, largely. And the telegraph is the first of these new electrical technologies. Samuel Morse, a painter, teaching at what is today New York University in New York City, had begun to try to develop this thing called the telegraph, a way of sending communication from one place to another instantaneously. And that wooden frame thing there at the top, this is Morse's idea of what a telegraph might be. So that's his receiver up there, and this is his transmitter. The transmitter is actually based on a printer's port roll. These are pieces of type with little bumps, and as this device comes over it, it makes contact, sends a signal, and at the top is a little device that records with ink, based on a painter's canvas stretcher. Morse was essentially using what he had available to him. His brother was the publisher of a newspaper in New York, so he knew about printing, he was a painter, he knew about canvas stretchers, and he modified those into his first electric telegraph. That was never going to work in the real world on a day-to-day basis. Fortunately, one of his students was this guy, Alfred Vail, at the bottom, who, working with Morse and at his father's Speedwell Iron Works, created a very simple transmitter, the key, and a very nice, beautiful, complex piece of mechanical machinery known as the register to record early telegraph messages. Later on, here's the electromagnet, and actually, when the signal arrived, a little piece of metal would come down onto the magnetized coil. It made a sound, and later on telegraph operators realized they didn't need the register, they could write out much faster just by listening to that sound. And so the key and sounder became the standard way of doing telegraphy, but this was the original system invented at Speedwell. Now, one of the things about the electrical and chemical industrial revolution is that it was much more grounded in science. Right? And so batteries, and in fact much of early electrical research came out of chemistry. Right? So Leonard Gale was the chemistry professor at NYU, or the college that today is NYU. And Morse relied on him for his understanding of batteries. And Gale knew this guy, Joseph Henry. Anybody ever hear of Joseph Henry? Who is it? First Secretary of the Smithsonian. He's the guy who essentially turned the Smithsonian Institution into the Smithsonian Institution. But before that, he was America's Michael Faraday. Michael Faraday, the person who did the most significant research on electricity in the first half of the 19th century. Henry did a lot of similar research, focusing on, particularly on these magnets, these electromagnets, but he didn't publish as profusely as Faraday did, so his work wasn't as well known. But Gale knew about him, and Morse relied on Henry's understanding of how these electromagnets might be used to both develop his instrument and to figure out how the system would work over distance. Right, because you had to, batteries could only send so far, you had to bring in relays to boost the signal and so forth. So science, both in New York and in Princeton, was crucial for this development of this new technology that took place in Morristown. Right? Well, the telegraph was also the beginning of this guy, Thomas Edison, who I worked on. And Edison is the one who changes the way in which we think about how invention takes place. So those machine shops, places like Speedwell, those were the industrial laboratories of the 19th century. That's where invention took place. So here's Edison, as a young telegraph operator, learning about electricity, from practical experience as a telegraph operator. That looks like a schoolroom. It's actually the operating room in Cincinnati, one of the offices that he worked in the mid-1860s. He was, however, reading people like Faraday, right? Trying to better understand the science behind this technology. But it was the machine shops that remained crucial. So in 1868, Edison arrives in Boston to work in the Western Union office there. And one of the first things he does is he goes to all of the different manufacturing firms involved in electrical technology. Now, why Boston? Because of Harvard and other colleges, and those early electrical manufacturers arose out of scientific instrument makers who were creating things for teaching, right, in the colleges and universities. And eventually, Boston becomes one of the centers for the telegraph industry because those are the people best prepared to take this new electrical technology because they've been designing instruments, batteries, and static electricity machines and other things that could be readily adapted. The guy at the bottom left, Moses Farmers, anybody ever heard of him? Okay, so he's the guy who co-invents the fire alarm telegraph, right? So the fire alarm began as a telegraph technology. So did ADT, the burglar alarm company, that was originally American District Telegraph Company. So there are all these things that were telegraphs at one time that today we think of as just electrical technology. The other guy you have heard of, his name is Watson. And I'm sure that rings a bell with some people, right? Alexander Graham Bell's partner. How did they come together? Charles Williams Jr.'s shop. This is one of the major shops in Boston. And one of the other people who worked in that shop, or had his instruments made in that shop, I should say, was Thomas Edison. Right, so this is his early vote recorder for legislatures. His first stock ticker design. Doesn't look like a stock ticker, but it was. He didn't invent it. I mean, Edward Callahan did. He's the same guy who invented the American District Telegraph, by the way. Nobody's ever heard of him. Edison was also working on a way of sending two messages over one wire. The most expensive part of the electrical system, all those wires, right? So if you could send two messages, you didn't need as many wires, reduced costs. But Edison takes his instrument up to New York to try it on a line between Boston and Rochester, New York. Excuse me, between New York City and Rochester, New York. And he's having some difficulties. He needs to do some design changes. And he's delayed because unlike Williams' shop, where he was well known, he had to kind of wait in line when he came to New York. So this was an important lesson that he learned. And so the Golden Stalk Telegraph Company, Callahan's company, knew about his work on printing telegraphs for stock ticker technology and hired him, right? And the contract includes a space to do experimental work with tools and machinery and a skilled machinist, right? Skilled mechanic. Edison takes that agreement and turns it into his first shop, the New York Telegraph Works. And eventually Edison, and in fact at one point he even had 3 different shops in Newark working on different telegraph and related technologies. He consolidated them all into one shop. Became known originally as Edison and Unger, later Edison and Murray. So the top left picture there is the Edison workers. That's his universal stock ticker that was used on the stock exchange, and there's a person that has a little print wheel. So it's sort of like a proto typewriter in a sense, right? Except it sends electrical signals out and prints the message. The exact same picture. These people are in Chicago. A company known as Western Electric, which began as a telegraph manufacturing firm. Especially central to that was a guy named Elisha Gray, who was one of the people considered co-inventor of the telephone later on. The Western came because Gray and Barton, Western Union invested in that company, and it became Western Electric. And Edison, 2 was somebody who was hired by Western Union, which took over the Golden Stock Telegraph Company that he'd been working for. Right? Now, one of the other companies that Edison is working for is a company known as Automatic Telegraph. And Edison has this technology that he can transmit up to 2,000 words a minute by machinery. Right? The problem is that when he takes it to Britain to do experiments there, because there they are using these what are known as automatic, but in that case ink recording systems, about 100 words a minute, 120 words a minute. So there's potential for this technology. He has all sorts of problems. The signal gets delayed, the message, he has, instead of a short dot and dash, he gets these elongated signals. What he discovers is what the British already knew, because they were the ones that had developed the cable telegraph industry, the big Atlantic cable that came across the ocean. The problem is that that creates all sorts of problems with how fast the signal can be transmitted. And the same thing with the underground lines that they have in British cities instead of overhead lines. And so Edison faces the problem that he doesn't understand this stuff, right? But the British telegraph engineers were paying attention to what they call these abstruse laws of electricity, right? And so the operations of researchers of the engineer materially advance our knowledge of the science itself, and the English telegraph engineer is essentially a scientific man. So science is increasingly important in these technologies as they become more complex. Sir William Thomson, Lord Kelvin, is the leading British physicist of the day. He's the guy who developed a lot of the technology that is used in the cable industry, including the electrical testing instruments that allowed both advance of electrical science and the advance of electrical technology. There were no galvanometers to be had in the US unless you purchased them from overseas. There was no manufacturer of them. Right? So Edison, as he had done when he went to Boston, in London he visits all the electrical manufacturers, and he discovers Elliott Brothers. And that's one of the instruments that we know he purchased that sits in the reconstructed Menlo Park Laboratory in Dearborn, Michigan. That's his list of the things he wants to acquire when he gets back to New Jersey out of that catalog and other catalogs that he acquired. By December, so he goes in the spring of 1873, by the beginning of December, he has a laboratory at Newark with every conceivable variety of electric apparatus and any quantity of chemicals for experimentation. He's not alone. So does Western Electric. But in both cases, they're still largely machine shops, right? So the laboratory for Western Electric is located in the third story and has ample accommodations for electrical, chemical, and scientific investigation. You know what else is on the third floor? That big machine shop, right? So the lab is just sort of carved out in some space in the machine shop, and that's what Edison did initially. But by 1875, he had arranged with his manufacturing partner to have his partner take over all the manufacturing, and that was now located in only half of the building. The rest of the building was going to be Edison's laboratory. And he actually draws up a long list of things that he's going to invent there. Some of them are telegraph devices, others are not, including another little electrical technology, the electric pen. Little motor that, as you write with it, creates a stencil. Later, a guy named A.B. Dick purchases that and some other Edison patents to create the mimeograph, which is originally known as the Edison mimeograph. So this is the first technology to come out of Edison's laboratory. But the problem is that Newark, because of all that industrial manufacturing, was also the unhealthiest city in the United States. Right? Pollution from other manufacturing and other industries. And so Edison moves to this little failed subdivision in Middlesex County known as Menlo Park. And he builds a laboratory with 25 by 100, 2 stories, right next to the Pennsylvania Railroad, so easy access to New York and Newark, with machinery and apparatus that cost about $40,000. It's a lot of money in that era. And he told William Morton, president of the Western Union, to come out and take a look at the unusual facilities which I have for all sorts of telegraphic invention, because the laboratory was filled with every kind of apparatus for scientific research. Okay? But it still had this machine shop, which was really important. And the shop was costing about $100 a week. He had 3 very skilled machinists who'd come from Newark with him. And Morton knew what he was talking about. So when this guy, Alexander Graham Bell, demonstrates his telephone in 1876 at the Centennial Exposition in Philadelphia, telephone was originally thought of as the speaking telegraph. So if you're Western Union, you need to be concerned about this new telegraph technology, right? So they agreed to pay $100 a week for Edison's research laboratory, the machine shop element, because that was what they understood. Right? Edison develops a really important improvement in telephone technology, the standard transmitter. And out of that, he also comes up with this idea for recording sound and playing it back. The phonograph, he becomes the Wizard of Menlo Park. His reputation as the inventor of the age emerges then. And that and his success in the telegraph industry lead a lot of people in the Western Union and related companies to invest in a new research project, the electric light research. They spent about $130,000, about $3 million over a period from the fall of 1878 to March 1889. It's an enormous amount of money spent on an entirely new untried technology. What Edison does with the money is he expands the lab. He builds a much bigger machine shop, because now he's going to worry about things like generators, not just small telegraph instruments. An office and library. The sale of the patent rights in Britain pay for all the books and journals that stock the library. And then the original lab you see there, plus some ancillary buildings for research. The staff, which had primarily been machinists and self-taught electricians like himself, now begins to take on a new cast. So PhD chemists trained in German universities, which led the world in chemical research. The first person ever to have a Master's of Science at Princeton, Francis Upton, who also studied for a year in Berlin. A scientific instrument maker from Germany, who became the glass blower for the work on the electric lamp. Later, a lot of people that were being trained in the new engineering schools in the United States would join the laboratory staff as well. Between 1878 and 1879, Edison essentially invented his generator and his lamp, and then over the next year, he expanded his staff, which had been about 25 by 1879 to about 60 people. Right? And so the first true research and development laboratory intended to develop new technology emerges out of this research on the electric light and this sort of team approach to inventing a system like electric lighting. Okay? So that takes place at Menlo Park in 1879, 1880. He's essentially created a new model for invention. Right? So it's not the machine shop, it's the machine shop combined with a scientific laboratory, combined with a group of researchers from different areas, engineers, scientists, machinists, coming together to develop these new technologies. This is a model that others begin to look at. So the Bell Telephone Company hires the fellow in the middle there, Ezra Gilliland. He had been a telegraph operator with Edison in Cincinnati and had become a telegraph instrument maker, and then got involved in manufacturing telephones. And he gets hired to run this new Bell Mechanical Department, where there's a lot of research going on in long-distance telephony. The problem with the telephone was you couldn't send the signal very far. In fact, that's Edison's real innovation, was making a transmitter work better over longer distances. But for real long distances, you still didn't have sufficient capacity in telephone technology. And so a lot of the research that was going on, and Edison was involved in that. You see in 1884, they even talk about a contract with Edison that he ends up not doing that, and then ends up doing other technologies. But nonetheless, this is sort of the beginning of R&D at the Bell Company. Right? Edward Weston, anybody ever hear of him? So some of you, Gary probably knows who Weston is. You probably know about Weston meters, right?
His son.
Yeah. So the company started with electrical meters for the electrical industry. Right? Weston did other work as well. He was involved in electroplating technology and other things in Newark. And he learned from Edison, hey, I'm going to build myself a laboratory. And he did. Right? And so what he opens up in 1886. One of the first inventors to really go wholeheartedly into developing an R&D lab for himself. Edison, of course, was highly competitive. Talking about Weston and other competitors, he liked to say that inventors needed enemies, right? And he and Weston actually had a little battle in the pages of Scientific American over the nature of dynamo design, generators. So Edison decides that I will have the best equipped and largest laboratory extant, right? Facilities incomparably superior to any other for rapid and cheap development of an invention and working up in commercial shape with models, patterns, special machinery. In fact, there is no similar institution in existence. This dwarfed what Weston did and what Edison himself had done earlier. There are 4 of these buildings, 25 by 100. You may remember that was the size of each floor of the 2-story Menlo Park Laboratory. So there are 4 Menlo Park Lab buildings right there, and the main building, which has 2 different machine shops, a very large machine shop for building railroads and railroad engines and things like that, and a smaller precision shop, which could build ladies' watches. And Edison talks about he can build anything from a railroad locomotive to a lady's watch. And he could at that laboratory. Right? He had a huge experimental staff as well as machine shop staff. So that's the experimental staff. And in this case, they were college-men almost entirely. Right? So this is the shift that takes place in this period, is that increasingly science-educated engineers and scientists, right? University-educated engineers and scientists are increasingly involved in developing new technologies. By 1903, the lab is surrounded by manufacturing shops producing batteries, various kinds of appliances like fans, movie cameras and motion pictures, and phonographs and recorders. Right? Edison starts those 2 industries, motion pictures and phonographs, as well as the electrical industry. Those take place at West Orange. But Edison is only very shortly the leader of the music industry. Right around the turn of the 20th century, Edison is far and away the leading manufacturer of phonographs and recordings, but soon overtaken by another New Jersey innovator. So the Victor Talking Machine Company is founded in Camden, New Jersey. A guy named Emil Berliner, who had done work for the Bell Telephone Company. In fact, his improvements in transmitter technology are very similar to what Edison was doing in the 1870s. In the 1880s, he develops a flat disc phonograph called the gramophone. And this guy, Edward Johnson, machinist in Camden, takes on this new technology. and becomes the head of what becomes the Victor Talking Machine Company. A lot of you may remember the old RCA Victor trademark, right? Began as the Victor trademark. This is the second iteration of this painting. The original one had an Edison cylinder machine. So why didn't Edison want that wonderful trademark? Well, this is one of the differences between the Victor Company and the Edison Company, and why Edison didn't succeed so well in this new entertainment industry. The Victor Company talked about the phonograph, or the Victor gramophone, as the world's greatest musical instrument, right? And it was the world's greatest artists that they were going to record, right? And that dog represented these values, even though on a Victor machine, you couldn't listen to your master's voice unless the Victor Company recorded it for you. There were actually Edison machines you could buy that you could record on, right? So in some respects, his master's voice is more appropriate for the Edison machine. But the reason that the Edison Company, and Edison in particular, didn't need that trademark is this guy. That's their trademark, right? All the advertising, almost entirely, is about Mr. Edison's pet and hobby, right? The phonograph would never become the great popular entertainer it is, but for Edison. It was Edison, the inventor, right, who was what the Edison Company marketed. The problem was, it wasn't necessarily what consumers were interested in. At the beginning of the technology matters. But as the industry matures, not so much. So, the Victor Company figures out that we don't want these horns in the middle of a living room. Build a nice cabinet, hide the horn. Edison has to follow behind, and he is following behind by this time, right? And what does Victor have? They have nice-looking machines, records with great artists on them. The Edison machine is still Thomas Edison, right? And when Edison goes to a disk machine, he focuses on high fidelity. In fact, the first, I don't know if you remember that old ad, is it live or is it Memorex? Well, Edison had a whole campaign around the disc phonograph. People would come in, listen to an Edison machine blindfolded, and there would be a singer and there would be a machine, and at some point they'd switch over. Right? Is it live or is it an Edison? Right? The Edison recreation disc. It was about really recreating the quality of a live performance. The problem was, Edison wasn't all that interested in whether or not somebody was a popular artist. Edison was going to make a science of music. He was only going to record those people he thought were best suited for phonograph recordings. Well, the problem, and you can see here in these surveys that were done, people sent back comments. They loved the Edison. The sound quality was much higher. Right? These